Hello, this is Dr.RameshBabu. Welcome dear ANSYS users. Today we will see about GFRP wrapped concrete cylinder when it is subjected to compression, what happens to the cylinder and how the delamination occurs, as well as we will be able to predict the confined strength of GFRP wrapped cylinder. So first we have to go to preprocessor, element type, then you add here solid 65, that is concrete 65 element, click OK, then close. Then you go to real constants and click add. So you can add the real constant. It is asking whether you have got any other real constants for rebar 1. If you have a reinforcement ratio, that you can mention as volume ratio, and the orientation can be mentioned. Since I am not reinforcing this concrete cylinder, I don't give any details of this, and I set the real constant number to be 1. Click OK, then close. Then go to material properties. So here we are going to define the properties of the concrete. Now first of all, let us say it is elastic, isotropic. So 5000 root FCK, let the FCK be 25. So 5 into 5000, you will get 25,000 Newton per millimeter square as Young's modulus of elasticity of the concrete cylinder. And Poisson's ratio I approximately give as 0.20. Then click OK. Then the density of the concrete is 2400 units. I assume that it is not reinforced, it is unreinforced concrete, so I give 2400 units. Then click OK. Then close this, directly go to modeling, then create key points in active coordinate system. Don't give any key point number here, just put 0 0 0. First key point is created, then you click apply. Then in the Z direction, the length of the concrete cylinder is 300 mm, that is the height of the concrete cylinder is 300 mm. Click OK. Then you go to this oblique view and fit view. Now you have the key point 1 created here, and key point 2 is created on the other side. So you click the dynamic model, and then if you click right hand click of the mouse, then you will get this in this way. So now we will create a line here, create lines, straight line. So this line is of length 300 mm. First of all, let me create the cylinder. So before creating the cylinder, we have to create the area. So click area, circle, solid circle. So X is 0 and Y is 0 and radius. The diameter of the cylinder is 150 mm. Let me give the radius as 750 mm. Click OK. Then the circle is created here. Then go to extrusion, operate, extrude, areas along lines. Click the area here and apply. Then it will ask for the line. Click this line. Click OK. So this cylinder is created here. This cylinder has a height of 300 mm and diameter of 150 mm. Here you can go to plot controls, numbering. Then here let us say that area numbers are on. So you can see that the area is created here. This is area 1. We note down the area 2, area 3, area 4 and area 5. So 2, 3, 4, 5 are the areas that has been created, and this is 1 and 6. Okay. So this cylinder has to be meshed with concrete element. So let us go to meshing. Mesh tool, set. So on the element type number is solid 65, material number is 1, real constant set is 1. Click OK. Then here you click lines and set the size of the lines to be meshed. Select this, click OK. Then element edge length you give 15. Okay. Click OK. Then go to mesh tool, hexahedral mesh, sweep the mesh, click this volume. Now you can see that the concrete cylinder is created. Then we have to create the GFRP wrap. Okay, so before that let us see that the top view, side view, everything we will be seeing. This is the bottom view. So this is the bottom view here. So from here X, Z and Y originates. So here let me click the element type, add, and you go adding a shell element, click OK, then close. Then real constant is not necessary for shell element. Go to material properties, material models, new model which is 2, click OK. Then you click isotropic. The approximate value of Young's modulus of elasticity for GFRP wrap is 80,000 MPa and Poisson's ratio is 0.25. I assume these values to be elastic and proceed further. And density is 2000 units. Click OK. And one more thing is here I have not given the stress strain curve for the concrete. If you want to give, you go to non-linear, elastic, multilinear elastic, and if you have the stress strain values here, you can give the stress strain values. If you have the values from experiment, you can give it here. Otherwise you can no need to mention. You click cancel. So these are the basic properties for this material model 1 and 2. Then you go to sections, shell, layup, add. Now here let me give the name as GFRP wrap. Let the ID be 3. Then the material ID here is 2. You understand? 2 is the GFRP, and here let me give 0.125 as the thickness. Then give 0.125 mm. Okay, so 10 times I'm giving, so that's why it is 1.25 mm thickness sheet. 0.125 0.25. The total thickness of the GFRP wrap is 1.25 mm. 10 layers are here mentioned, and orientation is along the hoop direction, that is said to be 0.0, and integration points you take it as 3. So this is over. I take section offset as mid plane, not bottom or not the top layer. Click OK. Then we already know that the areas are 2, 3, 4, 5. So we have to create the layer of areas for GFRP wrap. So let me plot the areas again. So here let me create a circle. So how to create a circle? Go to modeling, create lines, arcs by center and radius. Center is 0, 0, 0. Apply. Radius is 75. Click OK. Then plot controls, numbering, let us say line numbers. Click OK. Now operate extrude lines along lines. So here you click this line, it is asking pick line is 5 or 17, so you click 17. Then here you click 14, then here you click 15, here you click 16. OK. 14, 15, 16, 17. Then you click the line here. Okay. Now another circle and another tube has been created. Let us see how it is being represented. Now here we know that there was an area 2 here. At this purple color represents the area 2. Now you can see that we can go for meshing here. So meshing, mesh tool, shell element to GFRP wrap. You have to create this. Then areas here, mesh. Before meshing that, we have to define the size of the lines. So click here. 15 is okay. Then click the mesh tool, mesh areas, quadrilateral mapped meshing. Click here. It is asking 2. No, it is not 2. So it is 7. Okay. Then here it is 10. So 7, 8, 9, 10. So here it has been meshed. If you want to see the GFRP wrap, go to plot control, style, size and shape, click display of the element. It will show you the GFRP wrap. Just see here, you can see that 10 layers are there. So these are 10 layers of GFRP. Okay. So plot controls, device options, wireframe. In wireframe mode, you can see the GFRP wrap and the concrete. So this is the GFRP wrap created. Inside you have concrete. That means if you have this view here, you can see that there are 10 layers of GFRP, and inside you have concrete. Fit view, then oblique view, then again you go to plot controls, device options, click wireframe mode. So this is the GFRP wrap. Then we have to go for contact pairing. Go to modeling, create. You got to create contact pair. Click contact pair, pick the target. So target is here, it is 7, right? Yeah. So here you can write 7, 8, 9, 10. Okay. Then next, contact. So contact means here it is 5. Okay. So 2, 3, 4, 5. So you click 2, 3, 4, 5. Click OK. Then next, you give coefficient of friction as 0.3. So coefficient of friction as 0.3 here. Create contact pair. Flip target normals. Finish. So contact pair is created. Then we got to apply the loading. So how to apply the loading? So we will say like this. Now in the next video we will apply the loading.